Hi, Math 2. This is our Unit 6, Lesson 8 practice problems, and they're from page 65 in our workbook. So I want to just give a few hints on these practice problems as you get started on them. The first one wants us to classify this equation given no other information. So first off, a couple things. I can get rid of a line because I do know there's several ways to write the equation of the line, but there's never an x squared or a y squared term in the equation of a line. Lines like we did in algebra or you did in junior high. Now, an exponential curve we did last year, but those were in the form of y equals b to the a power, if you guys remember, b to the x power. And so this definitely doesn't have anything of that form. So I know that it's not going to be an exponential curve. That leaves parabola and circle. So I want you to note this y squared term. That's what's telling me it's a circle. My circles in lesson 4, 5, and 6, I believe, or maybe it was just 5 and 6. Circle equations had an x squared term, a y squared term in them. When I'm working with a parabola, my parabolas would not have had a y squared term. They would have just had an x squared term when I simplify it. So number 2 is really the main point of our lesson 8. It says to write an equation that states that a point, xy, is the same distance from a focus 1 as it is from the x-axis. This means my directrix is the x-axis, which we can also write as the line y equals 0. So this is using the form of the equation x minus a squared plus y minus b squared equals y minus k squared. This is an equation for a parabola. It's also on my formula sheet. So my AB is the 4, 1. So this is x minus 4 squared plus y minus 1 squared. And then my k is 0, y equals k. So this is y minus 0 squared. You can also write y minus 0 squared as just y squared. So another way to write this answer is x minus 4 squared plus y minus 1 squared equals y squared. They're both the same thing. So number 3 was the tough stuff. This was the problem we had to sometimes solve for y. So let's take a look at this problem. It says select all the equations which would describe a parabola with this focus and this directrix. Okay, so let's do it just like number 2. And let's write the equation just like we did in the problem above. So this is my AB, my focus. So I have x minus a negative 1 squared plus y minus a negative 7 squared equals y minus my k, which is 3 squared. So first of all, a minus minus is a positive. So it's really y plus 1 squared and y plus 7 squared. So this was my AB, my focus, and this is my y equals k. So that's what one of the main things I was learning at the beginning of the lesson. So let's take a look at my choices. That looks like B would be one of my choices. It matches B. Okay, so now I need to solve for y. I'm not sure which one of these choices work. I have to solve for y. And we did that 2 times in the lesson. And I think that the algebra to do that is, it was something that we had to work on. So first of all, remember our step 1. We're going to leave the x term alone. So I'm not going to do anything at all with the x term. So my x plus 1 squared stays. Now my 2 y terms, I'm going to multiply those out. So if you're a box method person, you're making your box out to the side, you're writing your y plus 7 and your y plus 7, and you're multiplying it out. So you should get y squared plus 14y plus 49 equals y squared minus 6y plus 9. So now we have to solve this for y. So this was my step 3. So usually I can subtract y squared from both sides and it cancels. And so now I need to isolate my y term. I've got to get y by itself. So I'm going to move, just because the algebra is less steps, I'm going to move my y term to the right. So it completely cancels from this side. On the left side, I have x plus 1 squared plus 49. And on the right side, I now have negative 20y plus 9. I'm still working on getting that y term by itself. So let me subtract 9 over. My 9's cancel. And I get x plus 1 squared plus, what is that, 40 equals negative 20y. I'm not done yet. I haven't really solved for y. So I'm going to divide by negative 20. I'm going to divide by negative 20. I'm going to divide by negative 20. And now my negative 20s cancel. Awesome. I get y equals a positive 40 divided by a negative 20 is going to be a negative, and 40 divided by 20 is a 2. So I've got my negative 2. And now my x plus 1 squared divided by negative 20 is going to give me negative 1 over 20 x plus 1 squared. Because remember, I'm not going to divide by negative 20. I'm going to multiply by the reciprocal. If you didn't watch the lesson video all the way to the end, I gave a little conversation about multiplying by the reciprocal from a previous math course somewhere where it's probably been looked at before. So you might want to take a look at that. So now I'm set to go pick out the equation that it matches. So it looks like it's matching E. So I'm going to match that up with E. Okay, ladies and gentlemen, so let's take a look at the next page and see if there's any hints I can give you here. So on the next page, here we go. It says parabola A and parabola B both have the x-axis as the directrix. Remember, that's y equals 0. And parabola A has its focus at 3, 2, and B has its focus at 5, 4. So it's starting to talk about, you know, what's wider, which one's wider, where's the line of symmetry. So it might be kind of good to take a look at what these parabolas might look like. So this is going back to lesson 7. When I was talking about the graphs of these guys, the parabolas. So let's do parabola A for a moment. I know its focus is at 3, 2, so over 3 up 2. So here's its focus, and its directrix is the x-axis, so this is the directrix. So I know my parabola from lesson 7, I believe it was the second activity. I know my focus is halfway in between, I know my vertex is halfway in between the focus and the directrix. So my vertex would be somewhere halfway in the middle. And I know when my focus is above the directrix, my graph points up. So this is a rough sketch. I'm just looking at my sketch of A. So now I'm going to look at my sketch of B. So sketch of B, so this was A over here. And so now I'm going to look at my sketch of B. So B, it's telling me it has a focus at 5, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. And the directrix is still the x-axis. Okay. So again, I know from lesson 7, the second activity, that my vertex should be halfway in between the focus and the directrix. So there's 4 units, 1, 2, 3, 4 here. So I know my vertex would be something halfway in the middle. And since my focus is above the directrix, I know that my graph would go up. Again, I don't know exactly what it looks like. That's a rough sketch. So in this particular one, I know that parabola A would be more narrow. And I know that B would be wider. How do we know that? Well, remember, the farther, the more distance, the more space between the directrix and the focus, then the wider my parabola is. Again, that's from lesson 7, the second activity. So since there's 4 units between the focus and the directrix in B, it would be wider than A, which only has 2 units between the focus and the directrix. There's only 2 units here. So then I know B would be true. The parabolas have the same line of symmetry. They do not. My line of symmetry goes down through the middle of my parabola. And so here my line of symmetry would actually be at x equals 5. And my line of symmetry for A would go down through x equals 3. So they don't have the same line of symmetry for sure. The line of symmetry for parabola A is to the right of parabola B. That's also not true. This vertical line is x equals 3. This vertical line is x equals 5. I know that by the x coordinate of the focus. So in that case, it's actually to the left, not to the right. So then I know that D is not true. The line of symmetry for parabola B is to the right of A. So parabola B has its line of symmetry at x equals 5, and parabola A has its line of symmetry at x equals 3. So 5 is more to the right than 3 is. And so 5 is further to the right, so that line of symmetry is further to the right. Again, that's kind of based on something you might have understood from algebra last year, so it's a tough question. Number 5, a parabola has a focus AB 5, 1 and a directrix y equals k. Where is the vertex? So again, this is going back to lesson 7. So if I could give this guy a sketch, 5, 1, 1, 2, 3, 4, 5. 5, 1 is my focus, and my directrix is -3. So 1, 2, 3, y equals -3 is a horizontal line through y equals -3. So there are 4 units in between my directrix and my focus. I have 3 units to get up to the x-axis and 1 more to get to 1. So I know that my vertex is halfway in between them. So my vertex is 2 units from the focus or 2 units from the directrix. That puts my vertex here at 5, -1. That's 2 units up from the directrix, 1, 2, and 2 units down from the focus, 1, 2. And so then I know that my vertex is at 5, -1. You also could have wrote the equation and solved for y and found your vertex that way. It's a lot of work to do it that way, hence why I used the reasoning that we learned about the graph in lesson 7. Okay, number 6, select the value needed in order for the expression to be a perfect square. Remember, that means your C term is b divided by 2 squared. So in this problem, this is ax squared plus bx plus c, so my b is 7. So this is 7 divided by 2 squared. That's 3.5 squared. So then when I square that, I get 12.25. So C would be 12.25. Thank you, and I will see you in our Zoom session to discuss this lesson more. Thank you.